Now, let us solve this problem, right? So here you have uh, five consecutive odd numbers. Okay, those are A, B, C, D, and E. Okay, which are odd here, and five consecutive even numbers. That would be 2D minus 8, 2D minus 6, 2D minus 4, 2D minus 2, and 2D. Okay. So sum of five numbers. Okay. So you got to add these. That is 2D minus 8 plus 2D minus 6 plus 2D minus 4 plus 2D minus 2 plus 2D, which is equal to 550, right? Now, this is 2D plus multiplied 5 times, which is 10D, right? And this is minus 20, which is 550. So we get D as 57. Okay. Now, in the given question, then E is, right? So if you look at here, so E will be 59. Here we have another problem. Let us look into this problem, right? Now, if we consider the product, right? So three consecutive product, that would be X and X plus 1, X plus 2, which is equal to 3,360. Okay, so this would result to X cube plus 3X square plus 2X minus 3,360, which is equal to 0. So now we get the answer as X as 14, and the consecutive numbers were X plus 1, X plus 2, so that would be 14, 15, and 16. So this is the sum of the squares of these integers will be 14 square plus 15 square plus 16 square, which would be 677, right? Let us look at another problem, right? So now here, what are the last two digits, okay, of 7 to the power of 1,000, right? Let us see the solution for this, okay? Now, there are two methods of solving this problem, right? Let us look at the one method, which I'll be discussing right now. So 7 power 1, which is equal to 0.7, okay? 7 square, okay? Mind that you have last two digits, so I'm representing 7 to the raise 1 is 0.7. Okay, 7 cube, which is 343. Can go on writing the values of to the power raise, right? So 7 power 5, which is 16,807. Now, the last two digits are repeated after every 4 cycle, right? So if you would have noticed at the last two digits 0.7, okay, and so on, right? Again, it has been repeated for to the power 5, right? Again, it will be repeated for the for the every 4 cycle, right? So now our 1000 raise is exactly divisible by 4, exactly divisible by 4, and gives the remainder as 0, right? So the last 2 digit will be 0, 1. Okay, let us have a look at the another method. Okay, you can also write this as 7 square as 49 mod 100, right? And 7 power 4, which is 49 square, which is 2401, which is equal to 1 mod 100. Okay, and 7 now to the raise 1000, right? So this is 7, this is 4 multiplied to 50, which gives 1 to the raise 250, or 1 mod 100. Okay, so and there's the remainder is 1, which implies that the last 2 digits of 7 to the raise 1 will be 0, 1. Okay. Now let us look at another problem here, right? So problem is um, how many turns of the sequence 21 by 2n plus 1, where n belongs to capital N, are integers. Okay, let us look at this. Suppose if I put n is equal to 1, so it is 21 by 3, which is 7, right? N is equal to 3, so 21 by 6 plus 1, which is equal to 3. So the answer is 3, right? Okay.